finishing up the sun. Let's talk about the sun's atmosphere. Here we go. The sun's atmosphere is known because of what are called Fraunhofer lines or absorption lines. Actually, the Fraunhofer lines were just the first ones that were discovered long ago in the early 1800s. Fraunhofer himself didn't know exactly what he was seeing, and unfortunately, if the great Isaac Newton, he just missed him. He didn't see that there were lines. You know, he's known for studying the rainbow and breaking up white light with a prism and showing that it was a rainbow of colors, but Newton didn't see that there was this hidden message inside. Fraunhofer did see them, but didn't really know what they were. And it took a lot of the 1800s to figure out what was happening. But using these dark lines within the rainbow of sunlight, we have found at least 67 of the naturally occurring elements on the sun. We know the rest are there. It's just we haven't quite detected them. And no surprise, the sun is mostly hydrogen helium. Almost all hydrogen helium, 99 point something percent, and everything else just trace amounts. Now, the sun actually has two atmospheres, they say. Astronomers say that the lower atmosphere is the chromosphere. Chromo means color, and it has this very distinctive pinkish color, hence the name chromosphere. Not much going on there. There are these little things called spicules that kind of dance around in the area of the chromosphere. I'll show you that in just a minute. First, though, let's look at the sun's entire spectrum, which is amazing. Here it is. So this became, we read an article in class called Starlight Detectives, and that's really what this was throughout the 1800s, was taking all of these dark lines that you see and trying to figure out which elements those represented, which was a huge task to undertake, but of course they eventually figured it all out. There's the chromosphere. You see the pink color there. So that's the lower atmosphere of the sun. The lower atmosphere of the sun. And here are those little spicules kind of right in there. Those little bitty things sticking up. They kind of dance around when you see a video of them. That's about it for the chromosphere. I don't know what else to say about it. But the outer atmosphere is the famous part, the corona. As you know, corona actually means crown in Spanish. So it's an appropriate name, the crown of the sun. And it's the upper atmosphere of the sun. And the time you get to see it is during a total eclipse, which we happen to have just a few months ago here in the United States, of course, was a huge, popular, seen by so many people here in the States, the 2017 total solar eclipse. Another one coming in the early 2020s, so don't fret if you missed it. But during that eclipse, one really neat thing that would happen, if you were looking at the spectrum of the sun, you would switch from having a rainbow background with dark lines, absorption lines, to having a black background with bright colored lines. Because at that point, when the sun is completely blocked out during totality, it's more like looking at a neon sign. You're looking at these very hot gases around the sun, and you get what are called emission lines. And that's the only time that happens. You see, the reason we only see the corona at that, during a total eclipse, the corona is always there. It's always there. It's just that the main part of the sun is so much brighter, that it gets outshone and you can't ever see the corona until it's eclipsed. The corona is amazingly hot, 3 million Kelvin. What's really amazing about that is, remember, the surface is like 12,000 degrees. This is like stepping farther away from a fire and suddenly you get warmer again. You're getting cooler, cooler, cooler as you step away from the fire. And then suddenly, magically, you're warm again. It doesn't seem to make sense. And for most of my career, this was considered to be a pretty big mystery. It's a very complex solution here, but they do think they understand now how energy gets transferred up into the corona to make it so incredibly hot. Again, not as hot as the core, but still incredibly hot, amazingly hot. So hot that it actually gives off X-rays, and we can study the sun's corona in X-rays. So pretty wild stuff here. Oh, my little video's not working. That's just the photosphere there and some sunspots. Here are actually both atmospheres of the sun. You see a little bit of the pink chromosphere, and then there it is, the ghostly, beautiful crown of the sun, the corona. So many gorgeous pictures. So many gorgeous pictures were taken just last summer in 2017. So that's it. Those are all the layers of the sun now. So from the inside out, we have the core, the only place where fusion takes place. Here's the core. Then you have the radiative zone where the energy is sort of free to fly. And then you hit the convective zone where it's going to bubble its way up over hundreds of thousands, maybe up to 1,000,000 years. And then that energy finally has a chance to escape as light when it reaches the so-called surface, the photosphere. That's where you have sunspots. It's where you have things like prominences and so forth. And then you get the two sort of atmospheres, the chromosphere and then the corona itself. But part of the sun, in a sense, extends further than that, and that's called the solar wind. Now, the solar wind, so-called solar wind, is a stream of actual particles. These are things like protons and so forth that are being ejected from the sun. So it is a physical thing, and it happens all the time. Technically, the sun is evaporating because of this. Millions of tons at all times are leaving the sun. So how long does it have left? Well, quite a while. This isn't a problem. After all the 4.5 billion years that the sun's been around, we think that it's lost less than 0.1% of its mass this way, which is just incredible that it can lose millions of tons of material every second of every day, and it doesn't even phase it. We do see some dark areas where we know the solar wind is coming from. They're called coronal holes, where the solar wind emanates from. Pretty interesting stuff there. You see a coronal hole there, a really big one there. Kind of a gap there. Probably done, that's probably, those kind of pictures probably done in X-rays or something like that. Not having much luck with my video clips. I apologize. I'll have to redo some of these. But anyway, it's a constant stream of particles. Now, when those particles get to the Earth, a lot of those are charged particles, things like protons and electrons. The Earth has a magnetic field. What do magnetic fields do to charged particles? They accelerate them. And when they accelerate them, they give off light energy. They give off light. And hence we have the northern and southern lights. Amazing, amazing stuff. You see, it actually forms a ring around the magnetic poles of the Earth. And just like a bar magnet, bar magnets, where are they strongest? At the north end and at the south end. Planets act like giant magnets, and they're strongest at the two magnetic poles, which, by the way, can be slightly off from the actual rotational poles. So the north magnetic pole, and the north pole, these are these are different terms. But anyway, I don't want to get into that too much. The main thing is that it produces light, these beautiful northern and southern lights. The different colors you see represent different elements in our atmosphere. You notice down here at the bottom left, you've got the oxygen produces the greens and the reds, and nitrogen will produce blues and violets. Let's take a look. Oh man, this is high on my bucket list of things to see. I just was talking to a former student who'd been in Iceland and had some epic pictures of the northern lights. Look at that. Oh, there's a shooting star there, right there. There's the Pleiades cluster, looks like up there. Really gorgeous. Just one of the many amazing things in nature that we have here on planet Earth that we shouldn't take for granted. It's in the southern hemisphere. You see the small and large Magellanic clouds, they're called. That's how you know it's in the south. A great view of the Milky Way. And just incredible stuff. And I think that's about going to do it for the sun. We're going to watch one more quick little video on the way out here if you'd like to see just a little bit of this. Just some highlights here of our active sun. I'll let this play here. If I can find the play button. There we go. For just a minute. Anyway, thanks for listening.